our 9981 wave that we just did the square root of and saw that it really is number one somehow. This is number one, or just as close as you can get to it without being it. Um, and take a universe wave, which is the expanded version of him. We're just going to divide them together. Of course, that's a good idea. Seems like, something obvious to do. So we do it, and we get this wave, and of course, we can see the sevens. And the neat part about this is we see the springs right up here in the calculator still. You see them actually, the wave depicted as springing up. And this is a wave that's created. So this isn't a collapse yet. This wave hasn't been collapsed. That's why you don't see any collapse. This is the superluminal wave that's just been created. So it's like a baby. It's out there cruising around. You can actually see the spring spinning, and we haven't even gone to the image editor. This is just a text editor, and you can see them spinning. Um, and a lot of stuff going on this way. Oh no, we are in the image editor. Sorry, but even on the other side, you can see um, him spinning. So you can see he's got all the functions of the waves. So it's we created a frequency and we've created a wave, and you can see the waves clearly moving through the answer. Remember, this is all the same answer, same 10,000 digits. We're not changing or touching the digits. We're just shrinking them, pressing them, and for some reason, pushing my arrow keys, which they respond to, and gives me the control spin the wave right or left or up or down. Even if I just push the right button and don't push the left button, you'll see that he changes shapes. Watch, he's going. Which way he's going there? Going to the left there, to the left, up to the right, and I'm not. I'm pushing the same button, the right arrow key. He's switching directions on his own. That would take a computer program. Tell it to do that. There's no computer program. This is just an image. There's nothing telling it to respond to the arrow keys. It's doing that on its own accord. There's nothing giving it those colors. Okay, it's getting those on its own, and all these images and stuff. It's doing itself. An RGB screen that's showing you these images is there's a collapse. Get partial collapse. Boom, with the white coming out. Now we could go down smaller and show you all the um, smaller processes going on, but I'm not gonna, because we're gonna go here and 999 209 987. So this is the answer we got. So now we're going to take this answer. So you see that's the same answer, and we've divided it now, this answer, by 411. Hopefully it's not the same as because this is a vertical wave. Look at the calculator completely interacting still with it, because this is all actually the wave collapse that happened in the calculator. So the calculator is still very much a part of this. This is all happening in a fraction of a second. But you see, there's a dial there, like a radio tuner. And all the stuff's going on with the calculator at this point. There's light waves. My calculator does not calculate with light waves. It doesn't use them at all. Again, we see unexplainable, and of course the wave collapse going up. Anyway, so we've got that same answer from over there. And this time we're going to divide it by the pilot wave, because that's what it was really asking for when I ran it. It was really asking, as far as I could see, for the ones. It didn't want fours or sevens or anything. It wanted the ones. So I divided it by ones, and here we have um, the result. Of course, the collapse is up here, and all the data has been organized beautifully and perfectly into this pattern. Um, and if we run it, we call it when we turn it on and start spinning it. Look at the light waves traveling through it. Look at them coming up into the collapse. Boom, boom. There's no doubt what's going on there. No doubt what's depicting, because the waves are coming in at 45 degrees. Well, that's the incident angle, even if it's from below. That means they're going to do exactly what you see them doing. They're going to reflect back into the main wave. There's no, at 45 degrees, the incident angle, the light waves don't escape. They all get reflected back into whatever it is you're looking at. So every one of these happens to be 45 degrees, no matter which way it's going. We see the waves coming in. There's no doubt those are waves. Um, not anything to do with the calculator. Here we actually see the skins of the waves again. So yeah, those are waves, and those are transverse waves. I recognize them because of the way they're flopping around like that. Transverse waves do that. Um, you wouldn't know that yet, but I can about that. These are, I don't know. You see, each type of wave has its own unique frequency and its own unique appearance. This is some type of cutter. See the scissors and the blades. Um, you can see up there the X's and the O things. Those are actually collapses. They're running along with us. That's not something a calculator's going to do. Oh, that was something. That was a Superman. There's the springs coming up. Boom, into the collapse. Boom, lighting up even as the waves get in there. Boom, you can see the collapse. Boom, lighting up. Now that'll be quite an extensive thing. Calculators try to pull off. Considering, see those U-shaped things? Those are the waves actually coiled as they spring up into here. So this would be impossible for any calculator that we have to do. Impossible for any mathematician that we have to do. I can't even do this. There's no way I could reproduce these type of effects. These aren't special effects. These are straight out of the calculator. Hollywood couldn't make these things. Nobody could make this type of special effects. Considering when you zoom in, the mathematical processes and everything going on in here is way beyond our ability to do. So, I'm trying hopefully to convince the last doubters that these are not answers from a calculator. These are clearly wave collapses. The calculator has no need or interest in providing any of this stuff, especially over and over, and they all turn into wave collapses. Quite beautiful. One more look at this on the invert to see if it looks really cool. Beautiful. These are all different processes, and we take it down since we're at the last one here. So we're all the way down small angle, which is 25%. And we see there's the plates, and they're hologrammed. There's no doubt about it. There's a hologram color. So these are reflective plates that the lights would bounce off of. And as it bounced off, coming back out, and this is what we would see, except this is inverted. So kind of what we would see if it was inverted. You see all the different colors, and it's bouncing off and growing. And this is a process as it comes to us in the calculator as 10,000 digits. This is what was happening in the calculator. Okay, nothing to do with the way calculators normally work. Look at that! Wow, boy, that's those are waves. Very lifelike. Agony kind of sketchy waves. Wow, but that's what's going on in the calculator. Okay, do you see a calculator? Do you see waves performing the actions? See waves. You don't see waves. There's something seriously wrong with you. But there is a lot wrong with mathematics and science right now. So I don't doubt that you don't see the waves. If you're a physicist or a mathematician, and it's just sad, and frankly, it's getting rather frustrating that the world has come to what it's come to. It's not just that we've been misled and we're not getting the truth about science, and we're getting a bunch of people that are just completely blind to the truth. This creates wars and deaths. The problem is people are fighting over these belief systems that are just wrong and completely on both sides. They're childish and they're ridiculous. There's X's and O's belief systems, but they're fighting. They're dying over them by the billions. While the truth that would end all of these wars and unite the world is spinning around in my calculator, and they won't acknowledge. They can't disprove me because that's impossible. It's not wrong. This is true. This is really happening, and anyone can do it. But they won't acknowledge it, and that's an age-old trick of the scientists started by Einstein. And it's sad, but they can't stop it this time because we have something that Bohm didn't have, and some of the other great scientists, but they tried to quiet and they were successful at. We have the internet. You're on it right now, so they can't stop us from doing this anymore. And that's good. And don't let them stop you from doing it. Now that you know this wave is real, try to hologram this image out again. All right, now we're going to go through the primes and the 417 and how they work together to create the primes in sequence and prime out the waves. One thing about the waves I've noticed is that they always tend towards the prime numbers, meaning the waves want to become prime. It becomes very obvious. And this is a clear reason why a wave would want to become prime, because waves primes don't propagate. So only non-prime frequencies can be broken down into smaller and smaller waves or larger and larger waves. Primes can't be broken down. And so the primes hold in these frequencies. So they can't escape, in essence, so that they can turn them into the primes. So the whole wave becomes prime. Once that happens, it's a very stable wave. It's not propagating, but it's oscillating. So it becomes like an atom, like a hydrogen atom. Especially on this pattern, on this cycle, these make the hydrogen atoms, which are, 90% of our universe is made of hydrogen. So that's where most of the waves end up, as a hydrogen atom, and then they can combine and make people and all planets and all kinds of stuff. So their goal really is to become this stable atom that's all primed out. So it's a little bit, this took a long time, a really long time to figure out. So hopefully I can explain it to where you can understand it. Starting with our wave that we've been working with. And you've seen a lot of unique things that this thing does, but this frequency does even more. It makes the primes in sequence, and makes the 417s so that the primes can perform all their functions. They can't just sit there in the pattern of the primes, because they have to, as you've seen, control the non-prime frequencies. They have to go on the ends of the non-prime frequencies to control them. So there's no way, it would seem, to get the proper sequence of the primes in there while all this other stuff is a harmonic series and everything's going on. How are you going to sneak this in? And I'll show you how they do that. First of all, we're just going to take our wave here and we're going to multiply it by 90. Okay, so 90 of these, x times y, gives us this 899, this frequency. Okay, if we divide it, we see we have 999. Well, 9 times 11 is 99. 9 times 113 is 999. 4 ones, 5 ones. So we see it's definitely the harmonic series of ones that we're working with. And we know that because we started with this number down here. So, and that's the harmonic pyramid of ones. So what we're going to do is go back to our frequency, this one. I'm going to take it and we're going to collapse this frequency. We're just going to divide it by 1, the universe, and we get this big 10,000 digit answer right here. Okay, so now in almost all the numbers, the primes are there in sequence, but it's very difficult to find them. You can't just like get a highlighter and go 01 and then find 02 next to it. And this is what I just did, but normally you don't. And then find 03 and then 05 and 06. It doesn't work like that, because if you highlight 01, let me show you what happens. 01, you end up with a ton of 01s, and but you're not going to be able to. And then you put like 02s and 03s on top of that, and you've got a whole mess on your page. There's no way to tell what's going on at all. So you have to find them connected to the 714s. If you can't find them connected to the 714s, then that way you get a 3-digit number, a 3-digit frequency, which is what we always want, our 3-digit frequencies. And that way you can narrow it down to just a few of these ones and a few of the twos and start finding the pattern. So it's very difficult to figure that out, and how it works. So I've got it done on this wave. So we want 0, 1 first of all, but we don't want all of them. So we're going to go with this little highlighter here, and we're going to go 801, and I'm going to hit enter. And we're going to find all the 801s, which is going to be a lot less, obviously, than all of the 01s. And whenever, I apologize, but whenever I'm using the camera, it eats up my memory, and everything takes forever. But I guess I'm taking forever. So we got a couple of 801s. Seem to be making some type of little pattern there. Okay, so we got 01. See it on the end? 01. So now we're going to go for the twos. And on this wave, I've checked out all the twos. And the one I found that was the best choice to make this pattern was 702. You notice why, obviously, because it's right below the 801. And the pattern goes all the way down. So we're doing good so far. Now we need a 03. So I came up on this one with 603. Oh, I put them in the wrong place. They won't stay there. So let me put in. I'm just going to go ahead, and you see what's going on here. I want to go ahead and put the waves in because I don't have much time. So we got 702, and we've got the next one was 603. The next one was 505, and the next one was 307, and the next one was 011. I'll stop there so it doesn't get too confusing on us. All at once gets a little confusing. And then I'm going to go ahead and put those in. All right, so you see we're starting to get a pattern here. We've got 1, 01, 02, 03, 07, 011. Now we're missing the 05. I had some difficulty with him, but we're not actually missing him. He does appear. So we're right there in the sequence. So 1, 2, 3, 4, 5. But he only appears once in the sequence in the proper place, but that's all we need. We only need once to make the pattern of the primes. So you see the pattern is rolling out in sequence. I'll go ahead and put the last ones in. Not there. Take that out. We got 813. 813 is 13. And 517 is 17. So see, I'm going in order. 319 is 19. And 023 is 23. And 529 is 29. Hit enter. And now you see we've got our pattern extended 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Now that's as far as we can get with the primes in this wave, or pretty much any wave, in sequence before they have to get to their other tasks. These are prime numbers now. They've got to hold in the non-prime frequencies and stop them from escaping. Now it's really interesting. Now that's where the 417s come in, because the cycle starts new now. So we're going to start with the 31 prime, but it's not going to be down here. It's going to start up here again, and the pattern's going to start over. But at the same time that it's doing this, it's also priming out the numbers. It's the 714s are going to come in here and prime this stuff out so that the primes become large primes. So that by the time this process is over with, not only do we have all the primes in sequence, but they've all been turned into large primes, and the wave's been primed out. And that's why the 714 is in every number, in every wave. That's what it does. It attempts to prime out the wave. And Sometimes it needs a little help, so it'll actually flash these, it'll project out the frequency that it wants, like 411, 717, or 417, because those are the collapse frequencies that'll help to prime it out. This wave doesn't need any help right now. He can do pretty much all of it on his own. We're not going to do the whole, because it takes a long time to figure out how every large prime in here and make sure you've got every spot covered. So we're not going to do all that. You can do all that if you'd like to. I'll show you how to do it. So we're going to go with 31, and we're just going to go here, easy way, 31. And we want to know where the 31s are on this page. So how can we get 31 in? And we see that there's no way you're going to get it in after 29. There's no 31 after the 29. But here it is right here at 31. So this used to be 19. Okay, it was, I think it was what? 319. But now the 714s have come in. Okay, the 417, sorry. Here's the 4, here's the 1, and here's the 7. They've come into the picture. So this makes it, in this case, they've made 97 a prime now, leaving us with 31. Now it's not down here where it should be because the cycle has started over. You can just forget about this first cycle. It's done. It's now, they're all primed out, holding in the primes, the non-prime frequencies. Then if they're not primed out, they will be in a minute as we add the more primes in. I know that's a little bit confusing. I hope you understand that. Now, as a matter of fact, like this wave here, I think it's that one. Yeah, this one. Actually, this entire number, 654, yeah, all the way to here, is a prime. So as the 4 and the 1 and the 7 come in, they've actually make a huge prime right, or big prime right here. And then it'll continue on. This 7, this 1, and this 4 will add up to make another large prime until they get all this stuff primed out. So it's a very delicate process. Very amazing how it's accomplished. I hope you can understand how that works. I've showed you the 417s, and they are, you know, everywhere in here. If we highlight the 417s, you'll see that they are just dominant in here, and they are the ones making the pattern. But again, to find the primes, you can't just highlight the 417s. It won't work like that. You have to carefully pull the wave apart piece by piece and figure out which prime is, which 3-digit numbers are making the primes in each wave, because it's different. So here you see the 417s added in. There's no way you can just look at them and say, okay, well, here's a prime 97, here's a prime 97, because you end up with a whole bunch of 97s, and you'll never find the sequence that it's actually operating on. And remember, the primes are a wave, so they're actually operating on a wave pattern. Okay, so it's very difficult to find. Also, notice that they're vertical. Okay, the primes are a vertical wave. They are inserted vertically into the wave. And vertical is a bad word because I don't know if it's vertical. These are flat waves. So vertical isn't very high when you're talking about a flat wave. You've got a little wiggle room. So it's more like these are horizontal, and the primes come in perpendicular to the horizontal waves. I don't really think it's probably not vertical. So that's how that works. And you can actually see, the other thing to notice is these aren't just random numbers that we've picked up, because all of these prime numbers, all these 714s, you can't see right now because they're all highlighted. Wait till they go away. But all these prime numbers that we've picked, notice they're on those lines that are already in this 10,000 digit number. These lines, these clear, the lighter colored lines, it's hard to see because I've got them all highlighted now. But you see there's these lines in here, which are made of 7, 1s, and 4s, basically. These are, every one of these primes falls within one of those patterns. They're not just out here randomly. Every one of them is on the lines that the patterns have made of the 714, which is the cutting wave. So the 714 has cut in this pattern, and the primes are on that. That's what's kind of left behind. The 714s are the ones that cut it in and made all of this happen, so that there'll be a pattern in this wave. And the pattern is needed. You see, it's definitely a pattern. The pattern is needed because that's how they make the hologram. Okay, without the pattern, they're not going to get the reflective, they're not going to get anything that's going to hologram. And this wave is very holographic. It's got the colors on it. It'll hologram, and we can run this as a wave if I save it as an image, and you'll see it's a pretty cool wave, but it's nothing spectacular to show you. But it's a, if you want to run it, you should know how to do that. There are a couple of other really amazing tricks that the waves have for getting the primes into the waves. And they're really great mathematical feats done by the waves, but this is the main way that it's always done, and I'll cover the other ways in the next video. There you have it. That's how the primes are made. There is no other way. This is how it's done. It's a very complicated process. It took a long time to discover this, and that's why nobody ever figured this out, because I promise you, if it wasn't for me, I don't think anybody would have ever got this. This was really complicated and took a long time and a lot of accumulated knowledge to be able to figure out what the heck was going on here. But we've got it now, and let me just say that what I've shown you about this one frequency, this 9801, is a drop in the bucket. This is one frequency. It's magical, granted, and it does amazing things. It's really great frequency, but I have many others that are equally as amazing that I haven't got time to show on one single video. But